Hey, what's up, guys? So, this is Vignesh joining you all today. We are in the sixth episode of the product development series, and it's going to be really interesting because we are going to talk about some interesting facts today. We are going to talk about the client side framework battle. That's what we are going to talk about today. And I guess there is a lag. I hope it will settle as and when we go along. But, anyways, so we are going to see what framework to pick, what client side framework to pick when you are actually going for building a web application or a full stack application. So what are the decisions you have to take, and why does one framework be better over the other? Like, what are the factors to basically take into account when choosing the framework of your choice, and why does one framework fare better over the other? That's what we are going to see today. And we are also going to look at why do we even need things like these. So without any delays, because it's going to be a big topic to cover, there are a lot of frameworks out there. So we'll jump right away into the session. So in case you have any questions, suggestions, comments, feedback, put it down in the chat, and I'll be answering all of that as and when I go along. So with that, so today we are going to talk about the client side framework battle, and we are going to talk about these frameworks, specifically taken into account. We are going to talk about Angular, React, Vue, Ember, Ionic, and even Vanilla.js. We will go deep and see why do we even need all these, and we will also see what are the pros and cons of each and every framework. So we will get a bit deeper into each and everything. So with that, so I still remember, I started web development around 2009, I guess. And it has been close to 11 years, and I have actually seen frameworks growing, gradually building up, the entire ecosystem actually building up when I am actually coding. And the thing is, there are a lot of things which are good for the community, and there are a lot of things which is a pain for the community. And let's quickly see. Let me increase the volume as well. Okay. Yep, there I go. So I hope I'm audible now. So there are a lot of things to take into account. Like, I started out as a developer when there was just HTML, CSS, and jQuery. So I still remember coding my initial websites in HTML and CSS without any frameworks. In fact, there was no concept of frameworks back then. Just code all the all that you want. You put your HTML, add CSS, and maybe whatever you are building, depending on whatever you are building, import the respective JavaScript libraries, copy code, import code, and make things work. So it was as simple as that. There was no build step, there was no transpilers, there was no frameworks, there was nothing like that. So, but then what happened was, when you talk about things like jQuery, you have a lot of code written all around. There is no structure. jQuery is a library. So that's where it all started. People started using code in the way they liked, and when people are working in large organizations, large systems, it was not scalable model. So if you want to scale your entire organization to thousands of developers or hundreds of developers, so the other developer must also know what code you have written. That's where the framework, the need for the framework actually began, to have a predefined set of rules and guidelines to basically make people actually write code in a defined way. So that's where it all began. So then it started building up things like, okay, now I am not just adding rules, but I am also making the developer's job easier. So let me add a library which helps, let's say, routing easier. Let me add a library which makes transition easier. Let me add a library which makes something else easier, data binding easier. So they kept adding libraries, and gradually these frameworks started expanding, and that's when a lot of big frameworks like Angular JS emerged. So then when Angular JS came into picture, that what happened was, if you talk about the evolution over time, and when you see Angular JS coming into picture, it brought about a lot of good things. It brought about things like data binding, where you had something called as a scope. So you had a global scope object for an entire view. You had a MVC pattern. So the MVC pattern was typically used for server-side apps, but then they brought the same pattern to the client side as well. So that actually brought about a lot of standardization, but it had its own drawbacks as well. The code started becoming more and more bloated. AngularJS code base, I don't know if you have actually seen AngularJS code base, but if you see the AngularJS code base, not the Angular, so there is a difference between AngularJS and Angular. So in case you are new to the framework world, you will know that. So AngularJS code base and Angular, then if you will easily notice that AngularJS is a lot bloated. It has global scopes. It has things like the entire view and controllers written in huge monolithic files. It doesn't have a concept of separation. Like it was like, okay, you either have to adopt Angular completely or you don't adopt it at all. And if you write an app in Angular, the problem was that AngularJS, the problem was that you cannot easily rewrite it to any other framework. It was very difficult because you use all the conventions and all the practices with respect to AngularJS, and if you really want to migrate to some other framework of choice, then it will be real difficult because you have to think in a very different way from what AngularJS actually does. So that's where the problem started emerging. So then a lot of frameworks started coming into picture, like Ember.js, there was Backbone, there was Knockout. So this is how it started emerging. New people started inventing more and more frameworks, trying to bring in standardization. But the problem was that they were missing some key points. Like one was performance. So it's not just about adding the boilerplate, it's not about adding the structure, but it's also about giving the developers the performance they need, giving the developers the usability they need, making amazing documentation, building a huge community. So all of this became part of the framework development process. This is where it all spanned out. So you started off with plain old HTML, CSS and JavaScript, then you came to jQuery, then gradually you started shifting to frameworks like AngularJS, and then the people realized, okay, performance is really important, because you cannot afford to have something like AngularJS where it's going to populate your entire DOM. And one more important part about AngularJS is it was slow because it was monitoring the entire DOM for changes because of its global object and data binding. So in that case, so it has to monitor the entire DOM tree to see where all things have changed. So it was very slow and it was not performant, and it was acting at the UI level. So meaning, if you notice the DOM tree, it's made up of a lot of objects. It's a huge nested tree. So you might have HTML, you might have divs, you might have divs. So if you see the Google source code, at least if you open up the Google website and see the source code, so it will be like this, a lot of divs within divs within divs within divs. So when you are traversing a DOM tree like that, and when you are looking for changes in the DOM tree, it turns out to be compute intensive. And you can't always be compute intensive, because ultimately when you are talking about JavaScript, your JavaScript is going to run on the user's browser. It's the user's system you are using, so you are going to consume up the CPU. So that's where performance started coming into play, because when you are using low-end mobile devices, it doesn't have the CPU power you expect it to have. So in such cases, what happened was, people who were using low-end mobile devices, the AngularJS website started crashing. So this is when, not just AngularJS, there are a lot of other frameworks as well. After AngularJS, there were a lot of copycats as well. So this is when people started thinking, okay, should I make it better? Should I make it better? And this is where people started building some amazing frameworks in the process. But there are a lot of negative sides as well. We are going to talk about all of them today. I hope this intro was good. Let's talk about the main difference between AngularJS and Angular. So one important thing which AngularJS learned, actually, if you notice, I made an entire website in AngularJS. And as soon as Angular came into picture and they said that I am not going to support AngularJS anymore, then it was a nightmare for me, to be honest. So either I had to rewrite my entire website into Angular, or I have to just give up the project. So that's how it was. So there won't be any community anymore. Yes, your website will still work, but how will security patches be done? How will there be enhancements to the framework? How will there be improvements in the features? How will there be new features? So I started facing all these problems. So that's why, to be honest, that's why I didn't move to Angular. So I had used jQuery, then I had used libraries like jQuery, then I had used libraries like Bootstrap. But when you use libraries like this, at least you had the flexibility that you are not writing all the code in Bootstrap or not writing all the code in jQuery, because those are libraries. But when you are bound to frameworks, it's like a marriage. So you don't, it's very difficult to move away to any other framework of choice. So that's where the problem started coming, and it was very difficult for me to move to Angular. So this is where everything started. But the approach Angular took was it made everything into components. So Angular JS was completely, a monolithic application, and Angular was completely based on components. You had multiple components, and you had views inside the respective component, and you had styling inside the respective component, everything within the component. And it supported things like ES6, and it was completely made on TypeScript. So that's where it actually stood out. So Angular JS was made on JavaScript, but Angular, and so it had to for supporting new syntax like the arrow functions, the spread operator and everything, it had to transpile using Babel. So but when Angular came into picture, they rewrote the entire framework into TypeScript. So this made the job of the developers easier and the job of the maintainers easier as well. So this way Angular took a better stand. But to be honest, I didn't move to Angular because I had a bad experience with AngularJS, and I didn't want to move to Angular and have it checked out as well. So I didn't move to Angular, but what I rather did was something different. I will tell you that in the end. Then there were other frameworks as well. Angular again operated in the DOM, so it didn't operate anywhere else. So you're still, yes, it made some optimizations like ahead of time compilation and other things. It optimized the V8 JavaScript engine, since it was the Google team who wrote Angular as well. So, and the Google team who maintains the V8 JavaScript engine as well. So they rewrote the entire V8 JavaScript engine to support the performance needs of things like data binding, to support the performance needs of the frameworks. But then the problem was that even if you rewrite something like a V8 engine, a JavaScript engine, if you are going to write code, or if you are going to write a framework which is not scalable, then it's not going to be easy for you to do anything for that matter. So what happened was, after Angular then came other frameworks like Ember. If you talk about Ember, what happened with Ember was they tried to make a framework which actually works well for all developers without any they didn't make it opinionated, but okay, sorry, I would suggest not put images like this, but anyways. So what happened with Ember was that Ember wanted to build a non-opinionated framework, or a opinionated framework, where you will actually just code your logic and not worry about anything else. So they built out the entire thing for you. They built out the routing, they built out the entire testing stack, they built out the navigation stack. So they built out the entire framework for you, and you are, as a developer, just focusing on the code and nothing else. So Ember was like, okay, we will do everything for you, you just focus on your logic. That was the approach they took. So Ember, again, it was not as performant as as other frameworks would be, but they made the job of developers very easy. So if you use Ember, you can write code very fast. That's a huge positive thing about Ember. And one more positive thing about Ember is that if you actually write code in Ember, and if Ember updates itself as a framework, it releases new features, it is very easy to update, because they have built-in CLIs as well, which actually takes care of putting the right files in right locations. So they took care of everything. They took care of putting the right file in the right place, upgrading all of your existing files. So they took care of the entire cycle, and you as a developer had to focus on just your code, nothing else. So this made the job of developers much more easier. But then again, the problem was performance. So performance criteria was not met. So, and not just that. So when you are actually already having legacy apps, let's say you have a legacy app written in some other framework. So let's say you have a legacy app written in AngularJS. So how would you even manage to migrate it? So this is where frameworks like Vue.js came into picture. So what Vue.js did was, so that's what Vue.js is called as a progressive framework. So what they mean by progressive framework is, so you basically take a piece of the entire product which you have built, and then migrate that into Vue.js code. Then take the next piece, then migrate that into Vue.js code. You don't have to look at the entire piece at one point of time. You rather take one piece at a time and migrate it one at a time. So this made the job easier for people to migrate. It's not just that. So frameworks like Vue, they adopted Flux architecture, which is the same architecture used in React as well. They supported JSX, and React also supported JSX. We will talk about React, but Vue made it very easy for developers to write code. It made entire framework as component driven, so which means that you don't have to rewrite the entire thing, you rewrite one piece at a time. And not just that, so a few other things, like if you take frameworks like React, what happens, React is not a framework but rather a library. So if you take libraries like React, what they do is they make you write CSS and HTML also within your JSX. So it's not called JavaScript, it's rather JSX. So you are putting all the code which you have inside JavaScript essentially. So which might have some advantages, but the problem is that you have been going with the separation of concerns as a developer. You put the HTML in the HTML file, you put CSS in the CSS file, and you put JavaScript in the JavaScript file. So these three had different responsibilities, and so the separation of concerns was very important. But then suddenly React came into place, and they said that okay, put everything inside JSX and we will render it for you. So, but rather Vue took a different approach. While they supported JSX as well, they supported rendering via JSX as well. What they rather did was, they also supported things like, okay, you can have your entire template inside HTML files, and you can have your controller as Vue, and then you can actually have the benefits of the components as well. So you also had a HTML file, you had a JS file, and you had a CSS file. The same way in which you would do conventional web development. It has its own advantages. So you have clear separation of concerns. You don't mix up things. The problem, if you don't put HTML inside JS, the problem is that you cannot leverage things like templating or all of that. But Vue was able to do that. So that's the major point. So Vue and React supported server-side rendering. Vue and React supported powerful DOM manipulation. It improved the performance, and both were component driven. So that's where it started picking up. So Vue was from the community, and React was from Facebook. So when React came, in fact React came before Vue. What happened with React is, so React, in fact if you see the reason why people built React at Facebook, there was a lot of communication or DOM updates which kept happening in the Facebook UI, and gradually things started becoming very, very complicated. So there was no standard for communication of the data between JavaScript and your user interface. That's where things started becoming a lot complicated. So are you saying Vue.js is like templating engine available in Express? It's not a templating engine. So if you talk about templating engine, the job of templating engine is only to take your entire let's say you have an expression within the template. The job of the template engine is just to evaluate the expression and put the value inside. Vue.js is not just a templating engine. It is also a component library which not just provides you ability to do templates, but also gives you a complete system where in which you can exchange data, you can bind multiple components. Like if you have third-party components, you can add it as plugins. So and it also takes care of things like DOM manipulation and everything. So template engine, the role of template engine is just to replace the data in the Vue. But Vue.js does more than replacing the data. It also does templating. That's just one of the features. So where did I leave? Talking about React. So React was made in Facebook to satisfy the use case where they had a lot of data exchange to and fro. You had JavaScript code written which exchanged data with the UI. There was regular UI updates which happened. So they had to regularly go and add multiple lines of code, to basically get things like, let's say, the notification counter incremented, or let's say, the chat working properly. If you go to the Flux website and you see, the video, from the Facebook employee, what they would have said is, there was a lot of data bindings which was happening. There was two-way data binding which they used before. And they don't have any structure on where does the data flow from and where does the data flow to. So all these problems were solved by React, and not just that. So since there were a lot of things which they had to update, the performance of the Facebook UI came down gradually. So it started loading very slowly or crashing a lot in the browsers. So they started thinking of an alternative where they can do server-side rendering, reducing the load on the CPU, and that's when React came into picture. That's when they invented JSX, a powerful templating system, and that's when React came into picture, where you have your entire. It's not JavaScript. React is not a JavaScript. It's a JavaScript library, but it's what you write in React is not JavaScript. It's JSX. So it's a language which gets converted into JavaScript when rendered in the server. So that's what happens behind the scenes. So when you added React, the most important advantage you got is all the DOM tree manipulations happened in the server, reducing the load on the CPU. So this way, the website started loading fast. But the problem is that you had to add a lot of things like build systems. Like if you have to convert your JSX code into your JavaScript code, you have to actually build it. So then there needs to be a compiler in place to actually convert your code into the code which runs in the browser. Not just that, so you had to put CSS, HTML, everything within JSX, as I told you before. That was another problem. But then all these things were actually seen as, it was taken as a standard by the developers, and they moved forward with React because of the lot of advantages it had. Because one of the important things of React is that you had libraries like React Native, which can actually where you actually write React, not pure React, where you actually use React, and then you can basically compile your entire mobile app from JavaScript or JSX to native code, which is in iOS or Android. So this made the job of developers easier, where they write code once and then get it converted into native binaries. But then not everything was smooth. In fact, if you go up and read, Airbnb was earlier using React Native. They migrated away from React Native because of a lot of reasons. There is a huge blog on that. You can go up and read it. So these are the things about React which makes it actually good. So now quickly moving on to the slide. So I talked about Angular. So which is the main positive thing about Angular is the component driven system which Angular made, and they had they rethought the entire thing. The performance was better than AngularJS. Everything was better, but it was a bit late for Angular because the entire market has moved toward React. So then I talked about React as well, which is written completely on JSX, made by Facebook. It had its own advantages. We will compare about all these frameworks in a moment. But before that, it's important to understand what these frameworks actually do, how they actually evolved. So and then came Vue, where Vue made it easier for developers to to migrate your app progressively, and also made it easier for developers to browse the documentation. It has a amazing documentation. It has an amazing community, and it was not backed by Facebook. So people who didn't like Facebook, they also went to Vue. So things like that happened. And not just that, so Vue also supports the same rendering system Flux which Facebook has. So they support things like dispatch, the same model which React has, which is dispatcher. You have a source, and then you have actions. So we will be talking about that. But anyways, yeah, this is what I was talking about. This is this is called Flux. This is what React as well as Vue uses. So what happened before was there was multiple communications between the DOM and your JavaScript code. But then Flux came into picture, and what it did was it introduced the concept of action. So any event which happens, any trigger is an action, and that action basically sends event to your dispatcher, which is like your traffic controller. So it takes all the event which comes to you and basically holds the event, or transmits it to the right store, right person at the right time. So that's what dispatcher does. It acts like a traffic controller for all your events. So let's say you click a button. Clicking the button is the action. So it emits the click event to the dispatcher, and now that event has to do something, right? So like let's say incrementing the value of a counter. Let's say that's the action you have to do. So the old counter value is stored in the store. So what you do is you go to the store, you update the value of the counter, and then what happens is you know, as soon as the store gets updated, the view gets notified. View is nothing but your, the HTML page or the rendering page which you are actually seeing. So the view gets notified saying, okay, a change happened. And now view gets refreshed. The entire DOM tree gets re-rendered. So this is what happened in Flux framework, and then the view was also able to trigger actions back again. So this is how it worked. So you had a complete cycle of events traveling through, and this is how React and Vue worked. But now this is not about React and Vue, and we also talked about Ember as well. Ember made the job of developers easy, since they followed, in fact, a lot of companies like LinkedIn, Facebook, lot of, not Facebook, I mean LinkedIn and Uber, I guess, there were a few other companies, Microsoft, all of them, partially use Ember, not completely, but some of their software is written in Ember. You can go to the Ember website and see who the customers are. So now, instead of talking about theory, okay, I will finish with Ionic, and then I will actually show you what the difference actually is, how the comparison actually looks. So now Ionic is where you have a framework for your mobile apps as well. So Ionic is not just for your mobile apps, but also for your desktop apps, for your websites. So it's misunderstood as a framework for mobile apps, but it can work, as a PWA framework. So wherever JavaScript and HTML and CSS work, Ionic can work. So Ionic is also a framework which which is component based, which is based on web components. So they use something called a stencil, behind the scenes, which is a component, component framework. What they do is, they took an entirely different paradigm where they said, okay, enough of this framework battle. I understand the positive side of React, I understand the positive side of Vue, I understand the positive side of Angular, and my community is completely divided throughout all these frameworks, and it's impossible for me to support all of these communities. So let me build something which can actually support all the frameworks. That's the direction which Ionic took. So meaning, what it did was, it made it based on web components. It's a framework based on web components, the native web standard. So in this case, if you talk about web components, what happened was, you had all the code which you write again in JSX, but it got transpiled into vanilla JS. So meaning, vanilla JS is nothing but plain JavaScript. So it got transpiled into plain JavaScript. So what happened ultimately was, the code which runs on the browser was plain JavaScript without any framework in place. So this also improved the performance, and not just that, it also made migrations easier as well. Since you are writing code based on web components, the thing was that you can actually switch components, you can reuse the component in multiple places, you follow the browser standards. So you leverage the browser as much as possible. So that's really important. So in fact, if you look at libraries like Polymer, the main motto they had is use the browser. So I don't know what the exact motto was, but anyways, their main agenda was, try to leverage the browser features as much as possible, and don't try to reinvent everything in your framework or in your library. So that's the same direction which Stencil or Ionic took, where they leverage the browser standard which is based on web components, and they build the entire stack on it. So that's how it started. And they also adopted design systems like Material Design for Android, and they adopted iOS flat design. So this way they were able to address multiple communities, multiple sets of users, and this is how Ionic came into picture. And this is the direction I have been using as well for my startup. I completely, in fact, I got frustrated a lot by web components by frameworks that I switched completely to web components. The reason is, while frameworks can be amazing, it can provide you a lot of standards, it can actually reduce a lot of work you do, but the problem is that, I don't like to get logged into any framework. So if I want to write code, I want to write code in the standard way possible, in such a way that I can migrate code whenever I need it without any difficulty. And not just that, I can make the migration as progressive as possible. So this is the reason, not just this, and I wanted to make code which is reusable in many places. So this is the reason I went for web components. which also gives you a standard way of thinking. Like you have APIs for the components, you have standard semantics like events emitted by the component. So you also have things like, what do you say, data binding to the components. So this is why web components are really good. They give you all the power of your frameworks, which is nothing but a structure. So, and also they give you the power of leveraging the features which your browser already has. That's why I opted for web components, because you also have amazing libraries like Storybook.js. So in case you have not seen Storybook, go check it out. It's an amazing component renderer where you can actually put all the components you have in your like a component toolkit in Storybook, and share that Storybook with other developers, and they can reuse it in their own code. So this way the code reusability will increase. You write code in vanilla JavaScript, or if you even want to put, let's say, React inside, if you even want to put AngularJS inside, or some other framework inside, you can always put it inside the web component as well. I don't recommend doing that because the component will become more and more bloated. The size of the JavaScript code you write will increase dramatically, but ultimately it's possible to do that. So in case you cannot have a component without JavaScript, but without AngularJS, but you need AngularJS only for that respective component, you can just use AngularJS for the component which runs on a specific page, and use native web components for remaining pages. So you have an option of progressively adopting frameworks or libraries or components when you go for web components. So these are the things. Now let me quickly go to the pros and cons of different frameworks. This is something which I got from a website. I won't walk through all the things, but it compares everything. It's not made by me, so I got it from a website. So if you compare React, Angular, Ember and Vue, so all of these are frameworks except React is a library, because in case of React it doesn't define how to do routing, it doesn't define how to do state management. That's all up to you. Meaning, so you can use your own state management library, let's say Redux or Mobex or something else. So it doesn't tell that this is the library which you need to use for all of these. So it just takes care of the DOM manipulations and your JSX code. So that's why React is a library, because it doesn't define the entire set of rules. And React is written in JavaScript. You write in JSX, Angular in TypeScript, Ember in JavaScript, and Vue you make a split between JavaScript and HTML. So you write all your templates in HTML, and you write all your control code in JavaScript. And of course, this is from Facebook, this is from Google, and this is both from the community. But still, even though it's from the community, it's still very powerful. So, okay, sorry. So then, of course, you see about the data binding. This is one way, this is two way. So in this case, React, as I told you about, the Flux framework, they go with one-way data binding. So that's what they prefer. So that's where you have the Redux model as well. So you have, where it is used. Modern web is where React is used, and if you want to use for native apps, then go for React Native. So that's why it's used for native apps as well. And in this case, the remaining cases, it's for web apps. And in this case, it's easier than Angular because you don't have to learn everything, which all the rules which Angular defines. You rather have to learn just about the rendering of the states and libraries, props. All of that is what you have to learn. If you go to Angular, you also have to learn about the entire architecture. So Angular is a complete framework end to end. So you have to learn everything, starting from routing, your state management, your controller code, everything. You have to learn everything. Of course, this is also having steep learning curve. This is Ember because it again defines everything for you. So Vue.js is a progressive framework. So you can learn gradually as you go along. So whatever you need to learn, that alone you can learn. So as I told you, React and Vue are based on Flux virtual DOM. So it renders everything virtually and then comes to the DOM. It doesn't manipulate everything on the DOM. So this way it makes your rendering fast. and this is based on MVC and this is based on MVVM. So I don't want to go through this. So again, development speed is normal, fast, normal. So this will just make no sense. I will share the link. So otherwise, this is the reason. You have to pick the framework which is actually good for you. Right now, the leading framework today is React, and second comes Vue, and third comes Angular, and fourth comes Ember.js. That's how it is currently ranked. So I mean, it's not Angular.js, it's Angular rather. So anyways, so that's the main difference between all of this. So now let me quickly show you something else as well. So in case you want to actually try out all these frameworks, you want to try out the difference between the code in all these frameworks, there is something called as To-Do MVC. You might want to actually check it out. To-Do MVC is a website where the same To-Do app is written across multiple frameworks and libraries. So like they write code in Backbone.js, Angular.js, Ember.js, Knockout.js. So if I was to write code today, I won't use things like Backbone.js or Knockout.js because it doesn't have that much community adoption right now as compared to React and Angular. These are, I would say old frameworks. And you can see the code, like for instance, if I want to see how this To-Do app is written in Vue, I can just open the To-Do MVC in Vue. The reason this has been done in multiple frameworks is to basically give you an understanding of what are the different things about different frameworks, and let's say you want to do benchmark of all the frameworks. You can do benchmark of To-Do MVC app across all the frameworks. So that way you have a consistent thing to measure against. Not just that, you also as a developer see what is the difference between all these frameworks, semantically, syntactically, and everything. So if you see about Vue.js, it has things like these. So you basically have a Vue object, you bind it to a class within your DOM, and then you have a data object, which is what you're populating to the DOM, and then you have a lot of things like this. So these are all the functions which are executed, custom functions or inbuilt functions as well. So you have an app which is running in JavaScript, and it's like a library. So you have app.js here. So as you notice, it's a JavaScript file, and you have routes.js for routing. So you basically add the router component from Vue. It doesn't mandate that you have to use router. It depends on what you want and what you don't want. So if you don't want to use router, you need not use router. So and you can also use the store if you want. So again, depends on you. So this way it makes it a bit flexible for you. And then ultimately, if you see the HTML code, all you see is your data binding everywhere. So there is a cloak, there is there are binding elements everywhere. You see this to-do.title, this is nothing but data binding. So if you change the title in JavaScript, it will reflect in HTML, and if you add something in HTML, it will again reflect in JavaScript. So there is a two-way data binding. So this way it makes it very easy for you. And if you see the same code in React, so you can go to the source. So and again they have all the files written in JSX, and if you see the JSX code, you see strange syntax. It looks like JavaScript, but it is not completely JavaScript. So it gets transpiled to JavaScript. You have a render function, which is where all your components, all the code for your component goes. So all the HTML code, and this is where you compute, manage all the different states. So in case you don't want to do this in this code, you can basically opt in for other state management libraries and move this to a separate block altogether. But this is how you go. So you have a to-do item element, and you don't bind directly. You rather connect your component. You write your component. You hook your component to the store, and what your store will do is it will listen to the new dispatcher, which is triggered by the action which you do. So in case you add a new to-do, so that becomes an action which is dispatched, and then your store changes where the new to-do is added. So you see all the state changes here: active to-do, completed to-do. These are different state changes. And if this state change happened, this is what you want to execute. So that's how React is actually architected. And the same thing if you see in Ember.js. So Ember provides a bit more comprehensive approach where, okay, I don't think they have the source code for this. I saw it, just a moment. So you have examples where I go to Ember.js. Yes, and here it is. I have my to-do MVC app. So if you notice, there is app, config, dist, public, test, vendor. All these are generated by the Ember CLI. You need not do anything. If you run the Ember CLI, everything will get generated for you. All you have to do is you have to get inside your component folder and then start coding. Inside your JS folder and start coding. So this is how you do. So you put in your JS. This is also a boilerplate. So it generates the entire boilerplate for you. So in fact, all of this is generated by Ember itself. And all you have to do is go inside the component and start adding to do item.js. So this is what you have. You have component.extend. Component is from Ember class. So you extend the component and then start building out of it. So if you notice, it defines a specific structure. It's very opinionated about what it wants you to do. So this way there is not much confusion which developers face, but then this flexibility is also a bit less than other frameworks. You also go with a high performance penalty because of this, because even if you are not using something, it might be still there in the framework, it might be still there in the library, so you don't have a component kind of a system. So I hope this was insightful. This is so in case you want to try it out, go to todomvc.com and you can actually try out all of this. All this code is open source in GitHub as well, so you can actually try out the code between all these frameworks. If you have to actually decide what framework to actually choose for your use case, then the way you go about that is that first of all, okay, take your use case and take one functionality from your use case. Try to build it out in 3 or 4 different frameworks, like what they did for TodoMVC. Let's say you are making a social networking app. So don't start making the entire social networking app in a specific framework, but rather let's say you need the post system to be built. So build the post system in React, in Vue, in Ember, and in Ionic and in other frameworks like whatever they have done for TodoMVC, because the choices depend on your use case. So you might want high performance, or you might want high usability, or you might want high stability or testability, or the community or documentation. It can be either of these, and it's very, very difficult to actually upfront say that this is the right framework for you. While there are leading frameworks like React and Vue, other frameworks are Angular, but it is very difficult to say this is the right framework for you, because you have to figure that out yourself, because your workflow will vary from everyone else. So take one component of your entire project, try building it in all the frameworks and see which performs better, which is stable, which is having the better structure, and which are you comfortable with, and go with that respective framework. But keep in mind that when you are actually choosing a framework, it's like a marriage. So you cannot get out of it very easily. So it's very difficult to migrate out of a framework unless you are using something like web components. So try to adopt a lightweight framework which doesn't enforce everything. So even let's assume tomorrow React is extinct. So if tomorrow, it won't happen, it's backed by a huge community, it's backed by Facebook, but anyways, you can't be, they call it as vendor lock-in. So you can't be logged into Facebook, or you cannot be logged into React. In such case, what you have to do is, so see how much your life cycle of the product is. So when are you going to re-architect or re-engineer your product? Let's assume it's going to be 10 years of time. So for 10 years of time, you can go with React, no issues. So React will stay for 10 years definitely. So, or at least for 6 to 7 years definitely. So if your timeline is going to be 6 to 7 years or 10 years, go with things like React or Angular or things like that. But if you want to make a product where you want it to stay as long as the web stays, adopt native JavaScript and web components as much as possible, because they are the standards defined by W3C. And if you notice, W3C standards, they don't change. I mean, it's always backward compatible. Like for instance, the latest browser today still supports the oldest versions of HTML and oldest versions of JavaScript. There are a lot of new features, but that doesn't mean that old features are not supported. So there is always backward compatibility. So it is always good to stick to web standards, because they cannot afford to re-architect the entire web standards, because huge amounts of websites, billions of websites are running on the web standard. And if they change the web standard, if browsers change the way they work, the entire web will basically go, I don't know, somewhere we won't want to expect. So in such cases, what they do is they make it backward compatible as much as possible. So stick to vanilla.js as much as possible. So in fact, I want to show you something very quick. So in fact, when I was starting off, people said, okay, I use vanilla.js. And I started wondering, okay, what is this vanilla.js framework? I want to learn that as well. I mean, I want to explore that as well. So I went to Google and searched for vanilla.js, and then I found this website, vanillajs.com. So, and it claimed itself as vanilla.js is a fast, lightweight, cross-platform framework for building incredible, powerful JavaScript applications. So I thought, okay, this is what I needed. So I needed cross-platform framework, I needed lightweight framework, I need a fast framework. So this is what I needed. And then I came down to checklist. I saw what I had to download. And if you notice, I had nothing to download. So I just had the code functionality, I had prototypes and everything. So in fact, if I even check all of these, I checked all of these, and then the final size came to 0 bytes. It's a funny website. So 0 bytes uncompressed, 25 bytes gzipped. Show human readable sizes. So 0.02 KB size, gzipped. So which means that you are not downloading anything. So I click on download. Let's see what you actually get. So I open this vanilla.js file. So this is what I got. I got an empty file, so which had nothing, and I did the same thing. I was clueless on what it is. Then I understood vanilla.js is nothing but plain JavaScript. So this is how I started learning web, and it was funny actually. So anyways, so thanks for attending today. If you have any questions, feedback, comments, or whatever it may be, let me know. So I hope it was informative. There are a lot of other things which I have to share as well, but I am already over time. So see you again tomorrow in the live coding series, where we will be continuing to build the live chat application. So stick around for tomorrow 9 p.m. IST, and we will see. Bye bye. And next product development episode will be on next Wednesday. So see you. Bye bye.